Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on yet another episode of the podcast we call Space Nuts. I'm your host, Andrew Dunkley, and with me, the expert in everything above your head is Professor Fred Watson, astronomer at large. Hello, Fred.
Hey, that's a nice, I quite like that, everything above your head, especially given that top of my head's fairly empty.
Well, it has multiple meanings. It could mean it could mean space. It could mean astronomy. It could mean hair. It could,
yes, anything. Yeah,
it could mean everything that we don't understand. So
that's right.
I like that. I might use it again one day. And how are you, sir?
I'm very well, thank you. Very well. Already raring to go, and very glad to be talking to you again.
I got a lovely note from a new listener. She's listened to 2 or 3 of our podcasts so far. I said, "Oh, you've only got 172 to go." And she said, "I better do some catching up." But she wrote a lovely email and asked a question that's not related to actually going into the podcast. It was more of an academic question, which I've passed on to you. But she was thrilled to bits to get a personal response, which that's the way I do it. That's the way I swing. I like to answer everybody when I can. And I told her you'd be hearing from her.
Yes.
Or she'd be hearing from you even.
She will.
At some stage. You're a very busy man. I don't dump on you too much, but...
No, that's all right. No, it will happen.
Yes,
that's all right.
From time to time. Now, we've got some really interesting stories to discuss today, and we'll tackle a question. There's a new theory surrounding the mystical Planet 9. We've spoken about Planet 9 2 or 3 times because they're still looking for it, but now they've come up with a new idea, which is quite interesting indeed, captivating even. We are also going to talk about the discovery of a galaxy cluster far, far, far away, I think was the headline. In fact, I think it's set a world record for the most distantly observed object or something to that effect. So we'll check that out. And we talked last week about Australia gifting NASA some Mueller, $2.50, I think it was, after GST was taken out. There's also further consideration to Australia's expertise in the mining and medical industries that could help NASA with their next mission to the moon. So we'll have a look at that as well. So first up, Fred, the hypothetical Planet 9. They have a new idea.
That it's not a planet at all.
Yeah.
There is a new paper which suggests that this object might actually not be a planet, but be something called a primordial black hole. And primordial black holes are thought to have been basically a consequence of the Big Bang. They're something that's been in the theory for a long time. We don't really have any observations that support their existence. But they are thought to have popped into existence more or less in the aftermath of the Big Bang as a result of density fluctuations at that early period in the universe's history. Now, as you know from the work that Stephen Hawking did in the 1970s, black holes evaporate. They lose their energy, they lose their mass through radiation. And they take a very, very long time to do that. But these primordial black holes are thought to be very small, and they evaporate quickly, and it's thought that perhaps many of them have already evaporated. But some of them might still exist, even though, as I just said, they've never been observed. Now, returning to the story of Planet 9, this object has been surmised by the alignments in the orbits of actually what are called extreme trans-Neptunian objects, things way, way beyond the orbit of Neptune, which are in highly elliptical or elongated orbits. And they are basically aligned rather well in a particular direction, the alignment of their elliptical orbits. And that's the main reason why people think that there is an additional planet out there that's basically providing the attractive force that's doing that.
So through their observations and through the mathematics, that something is out there affecting these
and it's something
Neptune objects.
That's right. And it's something with a mass between half and 20 times the mass of the Earth. That's the current theory. Now, I guess perhaps one view of what that might be is a free-floating planet that's been captured by the solar system. In other words, the gravity of the sun's grabbed onto this thing. Yeah. And there you've got Planet 9. So what the authors of this particular new research have looked at is the likelihood of that capture scenario compared with the solar system capturing one of these primordial black holes that might be lurking around. It turns out to be about the same. So what it means is that if it could be a free-floating planet, yes, it could. But it could also equally well be a black hole. Now, this is a black hole, say, around 5 times the mass of the Earth. It would have, I love this bit, it would have an event horizon around about 10 centimeters in diameter.
So we think of things in astronomy as enormous. And so when you say something like that, it kind of goes, what?
Yeah, I think if I remember rightly, the event horizon diameter, I think it's the diameter for the Earth, is about 18 millimeters. I wrote about that in Cosmic Chronicles, but I don't have a copy, so I can't.
That's because you sold them all, Fred. They're all
gone. That's right. I don't even have one for myself at the moment, so I can't look it up. Of course, I could look it up because I've still got all the files. But yeah, so anyway, it's basically a few centimeters that we're talking about for the size of a sort of Earthish sized primordial black hole. So how do you find it? Well, what the proposal is from the authors of this paper is to look for the annihilation signal from the dark matter microhalo around the primordial black hole. Okay. We don't really know what dark matter is, but it could be that dark matter and anti-dark matter annihilates and would give a signal that might be present in X-rays and gamma rays. So what they're suggesting is that there should be dedicated searches for moving sources, basically, with X and gamma ray radiation. That's a really interesting thing because the gamma ray sources that we see in the sky and the X-ray sources, well, gamma ray sources are very brief, so you don't see them moving at all. But the X-ray sources, of course, are all things at great distances which are not moving across the sky at all because they're so far away or not seen to be moving. But if you've got an object that is moving slowly through the stars of the Milky Way, which is where we think hypothesized Planet 9 is, and it's rich in X-rays, then maybe this is the answer, that you're seeing the annihilation of the microhalo around a primordial black hole.
So up until now, we've been looking for a solid object. We've been looking for a planet, and it's proven elusive. We also know how very hard it is to observe a black hole, and we've only recently photographed one for the first time in history, and that's been published. So where does a primordial black hole fit in the scheme of things in terms of being able to observe it? You said we think they exist. We've never seen it. We can't prove it yet. So could this kill two birds with one stone? We observe the primordial black hole and solve the Planet 9 riddle.
Yeah, that's right. So for the first time, we'd observe a primordial black hole. So exactly that, killing two birds with one stone. I like it.
Yeah. Well, obviously there's a lot of work going into trying to find this thing because it's close to home for us. We on
our doorstep.
Yeah, we really need to see what's out there.
If that was discovered, the first thing that would happen would be people would be thinking about sending a space mission.
I was about to ask that very question. It would take a long time, wouldn't it?
It would take a while, yes, because it's a long, long way out, but it's still a lot nearer than the nearest star other than the sun.
Yeah.
So,
Well, we've already proven we can send things vast distances, and with today's technology, getting there and the instrumentation required to do recordings and readings would be fairly simple compared to the 70s. So that in itself is a bonus. But yeah, we've got to find the darn thing first.
that's the problem.
All right. Interesting new theory on Planet 9. It could be a primordial black hole. You're listening to Space Nuts. Andrew Dunkley here and Fred Watson there. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
3, 2, 1.
Space Nuts.
Now, I just want to remind people about our YouTube channel, and we're building up quite a little audience on YouTube. If you're a YouTube subscriber, maybe you'd like to subscribe to the Space Nuts podcast via YouTube. They've even got a play all button, Fred, which means that you can just hit play and listen to all 173 episodes non-stop. I reckon that's pretty cool. We're aiming to get 1,000 subscribers. We're up to 335 as of this moment, which is fantastic. But if you would like to subscribe to our YouTube channel, it won't cost you a brass razoo. YouTube.com/C/Space Nuts. And yeah, go for it. You don't have to, but if you want to, it's there for you to peruse, or actually you get to listen to it as well. Now, Fred, let's talk about this idea of using Australian technology to help NASA with their next mission to the moon. We're talking about mining technology and medical technology in a remote sense, because let's face it, when we go to the moon or wherever, you can't sort of break your leg and then go to hospital, or you can't sort of get someone to drive your truck for you. There's all sorts of things to consider with these remote places. I mean, we went to the moon in the 60s, in the 70s, but looking back, we probably did it in a pretty radical way. I'll put it in those terms compared to the safety. Compared to the safety terms of today.
That's right. It's very high risk, and we're much more risk averse these days. So this story covers many bases actually, but it's all about really the fact that we now have a fairly close relationship between Australia and the United States in their space agencies, thanks to the announcement by our Prime Minister Scott Morrison a couple of weeks ago that Australia will contribute $150 million to the US mission aimed at sending humans to Mars via the moon, or to the moon and then on to Mars. And we know that most of that money is expected to return to the Australian economy, because it will be all about Australian technology being used. And just to comment briefly, that's exactly the kind of thing that we're good at, is making autonomous vehicles that can actually do their own thing and think about it and be safe as well. They're used very much in the mining industry, particularly in the Pilbara region of Western Australia. They have driverless haulage trucks, which are actually run from the city of Perth, which is about 1,000 miles away, 1,600 kilometres. So that is technology that's fairly well developed in Australia and may well have an application to the exploration of perhaps the moon, where maybe ice mining could take place near the South Pole region.
I should point out too, these are not small trucks.
They're not. No.
These have got tyres that tower over a tall man.
Yeah. In fact, probably two tall men.
Yeah, they're pretty amazing.
You need a big ladder to get into the driver's cabin, one of these things. Maybe that's why they don't have drivers. So, yes, there's all sorts of contributions that this kind of technology could make. And you're quite right, it does have implications for any kind of medical emergencies and things of that sort as well.
Yeah, so there'll be a lot of work to be done into the future on that. But I would imagine that the capacity to drive a remote vehicle on the moon from Earth wouldn't be that difficult, because I think you'd almost have real-time control compared to Mars.
Yeah, that's right. Although it still would need to have a degree of autonomy so that it didn't really, accidentally drop into a big hole before the signals got back to Earth to say, I'm dropping into a big hole.
Yes. Ground tracking radar or something like that.
Yeah, there will be technologies, I'm sure.
All right, watch this space. Now, Fred, let's just move straight on to our next story, and this is the world record discovery of a distant galaxy cluster. So distant, in fact, we're looking back 13.8 billion years or thereabouts. So we haven't looked any further than this ever before. It's about 13 billion light years away, I think, is the
that's correct.
Is the distance we're talking about, which is only a fraction short of the time of the Big Bang. So we are really looking way, way, way back in time.
Yes, exactly. So you're looking back to a time when the universe was 800 million years old, which is round about 6% of its age at the present time. So it's a long way back. And of course, the key to this is the finite speed of light. So what we're doing is looking at very, very distant objects and seeing them as they were at this time in the past. Why is it a big story? Because this is the earliest that we've seen a cluster of galaxies. Individual galaxies have been found already at this very early period in the universe. But to find a cluster essentially tells you a little bit more about the way the structure of the universe evolved. And it shows that galaxy clusters were there at this very early time in the universe. The thinking is, as you and I have spoken about before, is that the web of dark matter that filled the early universe basically acted, and it was a web with resembling a kind of honeycomb, I suppose, a three-dimensional honeycomb of dark matter, which acted as the seeds for the locations of galaxies, because the dark matter attracted the hydrogen that was in the universe, which collapsed and formed stars and galaxies. And so maybe in some ways it's not surprising, because we think that web of dark matter came very early in the history of the universe. And so to find the fact that galaxies themselves are congregating around the center, the high density centers of dark matter, is what you'd expect. You'd expect to find clusters of galaxies, and this basically proves that that is the case. It has a very, very nice name. It is called Z660D.
Yeah.
It's got there is a giant galaxy within it. This is often the case with clusters of galaxies. You find a giant galaxy near the center, and this one basically also has a giant galaxy, which is known by a rather nice name. It's Himiko, which is a mythological queen of ancient Japan, because this study has been done by Japanese astronomers. So that giant galaxy is one that you'd expect to be sitting near the center of this cluster of galaxies, because that's the way we see these objects in the universe today. When you see a cluster of galaxies in today's universe, the big galaxy, the kind of nucleus galaxy, is right in the middle. But Himiko isn't. It's quite a long way from the center of this baby cluster, perhaps 500 million light years from the center, which is kind of nowhere near, really, isn't it?
Yeah, but it is part of the cluster. And I understand that the way they were able to determine its distance was through something we talked about last week in response to a question about blue shift. They were able to read the red shift. Was that right?
Yeah, that's right. That's how you determine these big distances. You look for the way the light is shifted to the red, because the further it's traveled, or the longer it has traveled through space, the further its light is shifted to the red by the expansion of the universe.
Dumb question from no one in particular, but is our galaxy part of a galaxy cluster?
Yeah, it's part of, something called a local group, which is a small cluster of galaxies. But there is we're on the edge of a bigger cluster. I can't remember which one it is. It's either Virgo or Coma. That's terrible, isn't it?
It's jet lag, Fred. I
don't know where we are. I'm still
jet
lagged. That's right, yeah. Who am I again? I don't know.
Who am I? What are you? Where did we come from? Well, that's what Fred is trying to figure out. But, fascinating that they've discovered an object or a galaxy cluster further away than anything else has ever been observed in real terms, and it has set a world record for the most distantly observed object, as far as I'm aware. It seems a bit contradictory to say it's a world record, and yet it's something that's further away than anything we've ever seen before. So how could it be a world record? It's a universal record.
It's an out-of-this-world record.
It is indeed, yes. You are listening to the Space Nuts podcast, episode 173. My name's Andrew Dunkley, and with me, of course, Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Another big shout out to our supporters via patreon.com. We are building numbers there, which is fantastic. If you would like to contribute to the Space Nuts podcast, you can do so at patreon.com/spacenuts. Pop along and have a look. If it's not for you, that's fine, but maybe it is. And, it's totally your call. It is patreon.com/spacenuts if you would like to be a supporter of the Space Nuts podcast. Now, Fred, question. We're only going to fit one in today because we're doing a bit of cramming because you've got to go and sell a book. Now, dear esteemed Professor Watson and Andrew, thank you for your previous on-air reply. I have another question, if you would be so kind. Yes, that is the question, Fred. By the way, we're finished. He says, this is from Wes Smith in Panama City Beach in Florida. Oh, what a horrible place. If fuel could be mined from the moon for a Mars mission launch from lunar orbit with consideration of all planetary alignments, would there be any economy in using the Earth for a gravitational assist to help speed that transit? That is a really interesting question. We've talked about mining on the moon and the fact that we could go there lightweight because we could produce fuel from the water ice that's there to make a return journey. But what if we sort of went, hang on a minute, we're already out of Earth's orbit or out of Earth's gravitational field. Why not just keep going? We'll get all our fuel on the moon and pew, off to Mars.
So that's pretty well what would happen, what you've just described, Andrew.
Okay, thanks for your question, Wes.
You're leaving, you're leaving. If you're getting stuff off the moon, then you'd haul your fuel up to low moon orbit. That means you've got to get a spacecraft essentially in orbit around the moon from Earth. That's fairly straightforward. Then you've got to boost it, though, to the right velocity to get it out to the orbit of Mars. And doing that from the moon is not actually that much different from doing it from Earth. You could, depending on what time of the month you do it, you could give yourself an extra 1 kilometre per second or a free 1 kilometre per second from the moon's orbital motion around the Earth. But it's not vastly different. So the only thing is, thinking about, all right, so you're there, you're leaving the moon. Would you use the Earth for a gravitational assist? It's possible. If you were really stuffed for fuel, if you needed to economize on fuel, and perhaps one reason why you might want to do that is if you've got a very large spacecraft that's very fuel hungry, then yes, maybe you could put your vehicle in an orbit that would actually not get to Mars, but come back and intersect with the orbit of the Earth, get a gravitational assist from the Earth, and then be boosted out to the orbit of Mars. But all that demands a lot of very careful alignment of the Earth and Mars. You might find you could only do that once every 10 years or something like that you wouldn't have many opportunities. And so I think what's much more likely to happen is, yes, you might well fuel up in lunar orbit, but then it will be a direct path by what's called a Hohmann transfer ellipse from the orbit of the Earth-Moon system directly out to the orbit of Mars without bothering to try and make a gravitational assist. I think it would be a very difficult thing to achieve. It's certainly possible, but I think in reality we'd wind up just going there directly.
Yeah. Of course, the other thing to consider is you'd also have to produce enough fuel to get all the way there. Would we be in a position where we would have to consider enough fuel to get back just in case we couldn't make it on Mars, like we could on the moon? Let's assume we've got that technology and we've started doing that. The first trip to Mars would have to double the fuel load, surely, to get back.
Well, yeah, that's right. Although you could send a robotic spacecraft to basically rendezvous with Mars, sit in Mars orbit or something like that.
Oh, already fueled up.
Yeah, my guess, Andrew, I've said this before, is I bet the first human flight to Mars actually doesn't land on Mars, but lands on Deimos, one of Mars' satellites.
Why do you think that?
Because it's a low gravity destination. You have much lower risk of getting stuck on the surface if you're in a low gravity environment like that. You can leave Deimos with a Toyota Corolla. You don't need a spacecraft. The escape velocity is 40 kilometers an hour.
Is that all?
Yeah, it's about 28 miles an hour.
You could actually get off with a decent push bike.
Yeah, push bike could do it as well.
When I was a kid, that's the fastest I ever got a bike up to, 40 kilometres an hour.
That's pretty good going.
Yeah, it was downhill with a tailwind.
I bet it was, yeah.
But, I had a Speedo on my bike. I could have probably gone faster, except it was one of those old Speedos that leans against the tyre, and they took a lot of effort to wind up, so I'm pretty sure it knocked off at least 5Ks.
Probably, yeah. Yeah.
But,
those were the days.
Yes. But it sounds like you could get off Deimos with a push bike.
Yes, with a bit of luck.
That's a bit of a worry, really, when you think about it. Yeah. But wouldn't it be disappointing to land on Deimos and go, oh, we're so close. We're so close.
Yeah, yeah. Well, who knows? Let's wait and see.
Yeah.
And we'll cover it on Space Nuts in 2035 when it happens.
Yes, indeed. Assuming there are no delays. All right. Wes, thank you so much for your question. Hope that covered it. And we certainly do love to get your questions and queries and comments. Sometimes people just send us their beautiful space pictures, which is fantastic. And I've seen a lot of them, Fred, popping up on the Space Nuts podcast group, people sharing their photographs, and there's been some amazing photography. One of our listeners is already a major prize winner and is going after another prize. So hopefully people are voting for him on the People's Choice Award there. If you don't know what I'm talking about, join the group and have a look. And thank you as always, Fred, for your contribution. I don't think we could do it without you.
Oh, that's very nice to hear, Andrew. I don't think I could do it without you either. So there you go.
Pretty sure you could.
Yeah. Anyway, we'll speak next time. It sounds great.
All right. Very good. Thank you, Fred. Professor Fred Watson, astronomer at large, part of the Space Nuts crew, as you are too. And thank you for joining us each and every week. We will be back again in a week or so with another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.